All right, so given k greater than 2 subsets, find 2. Why k greater than 2? Does the problem not work if k equals 2? Okay, let's see. R minus, so I'm looking at the number of missed elements, right? Because of the way the expression is formatted. Um, so I want to miss at most nk over 4k minus 1. Um, yeah, it feels like an EV. Um, give me a moment. So, hang on. So, I mean, yeah, everyone's saying EV, and I agree. Pick 2 sets at random. The question is, how can I... Do I want to look at the expected intersection? That doesn't feel right to me. Um, yeah, it's not, this is one is about missing. It might be I want to like fix one of them with some property and then take the others randomly. Yeah, it's on you want to miss at most so many elements. Um, and somehow you don't care about the size. So okay. Um, okay. Okay, how about this? Make a big table. Maybe it's easier if I just make a big table. And in that table, what I'm going to do is, so in this table, there's going to be some elements, right? Like the first set, A1, we'll just call it A1. The top will be indexed 1 through n. In the bottom, you have some set A1. And then there's like some, the set has some elements. Now, anytime below each star, what I'm going to do is I'm going to say, okay, I'll put a big X if there's, if A1 has an element and A2 doesn't have that element. Oh shoot, I'm going to put an X like that. And my idea is I want to double count the X's. So assume for contradiction, that any intersection misses a bunch of stuff. Misses more than nk over 4k minus 1. Then what that means is, oh shoot, actually if I put the x's this way, it's very clunky. Maybe it's okay anyways. Maybe the bound's bad enough that I can get away with this. I don't, this bound is horrible. Yeah, maybe the boundary is just so bad that this will work anyways. So, okay, let's just try it and see what happens. And if it doesn't work, then we can figure out how to refine it. So the number of zeros will be at least. So I can take any k choose 2 pairs. Each of them generates at least a bunch of bad things. And then each thing is counted at most like n minus n minus 1 times? That bound feels really bad. Sorry, k minus 1. That feels awful. That doesn't involve r, which is... Hang on. Sorry, I didn't... And somehow it failed to involve r, which is really bad. Okay, you know what? Let me do it. What are we talking about? We have a problem. We just started. We think it's global. We don't know much else. So let's count triples. X, I, A, J, such that X not in AI. X not in AJ. Forget the table, okay? That actually made it more confusing. This is what we're counting. This is the data structure that I want. Forget the table. So assume not. Then we count the number of triples. On the one hand, if I do it by the pairs, I find that there's at least we can count intersections if you want. Like that's okay too. Okay, let's count. Okay, fine. We'll count double. We'll count ones. So if miss, so on one hand, it's given that you get worse than, like on the other hand, less than k choose 2 times that fraction. On the other hand, it's at least something, right? You expect some intersections because Jensen. So it's the sum of something choose 2. What is that something? It's the average number of sets in each column. So number of times x appears summed across the x. By Jensen, this is the total number of appearances is k times n, r times n, and you're dividing over k. Okay, yeah, I think that's where we're at. Kr over n. Yes, Kr over n is correct. So, conclusion is something gross. Rk over n times Rk over n minus 1 times 1/2 is supposed to be less than k minus 1 over 2 times yeah, I will say after doing this problem and Grant's problem, I think the global problems, it's common that you run into expressions that look like this. And it's just like look very strange. So the question is this a problem? This is what's happening. So for Yingwan to clarify, what's happening is we're looking at how do you count good triples. One way is you can count by if you pick AI and AJ first. When I pick an I and J, it's at low sat. On the other hand, if I pick by X, the number of triples generated for every element X is the number of times that element appears, choose 2. For example, if the element X appears like 5 times, it will appear in 10 triples. I don't know what that was all. So it's equal to this sum from like across the n elements. And this by Jensen, if I am not being stupid and drop the factor of n in Jensen, is n times this binomial. Okay, cool. So now I need to simplify the expressions and see if they match. So uh, the huh? So if I cancel a ton of stuff, this doesn't look good. It doesn't look like the expressions match up. Did I mess something up? Oh shoot, I put the k minus 1 in the wrong place. The k minus 1 should go inside and knock out that. I feel worried because I feel like the dimensions aren't even right. Like somehow this problem has some notion of dimension, like the degrees. Like R, K, and N are all counting number of elements, and these don't look the same. Like it should be degree 3 on both sides, right? So why did I drop K, N, R, 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 okay. So left-hand side is degree 2 now, right? Oh, actually no, the dimensions are okay. Great. So what do I do with this junk? I guess the minus R, there's a minus R that actually cancels. Okay. So the minus R cancels, and then, sure. R squared K N should be less than K times, oh, so there's a K that cancels too. R minus N quarters, which is the same as 1 over N, R minus N halves squared less than 0. All right, and that's a contradiction. All right. All right, we did it. Yeah, forget the table, just count the triples. It's actually easier to think about. Thanks, Dennis, for the chair. Yeah. See if I can do that. Yeah. Are you really from MIT? Funny. Someone was complaining about that on the ladder again today. I was playing some team games with MIT StarCraft Club, and some people got angry at us because our clans were all MIT, and they were like MIT geniuses, F you, or something like that. I really, I don't know. Something about the MIT clan tag really sets people off. What is an MTIP? I don't know. All right. We have the N5 left. Do people still want to do the N5 or switch to Baba? All right, MIT sets off the studios. Or other game. Okay. All right. Pull. New pull. What to next? Thanks for all the cheers. Confusion. All right, here's some options.